Next up, space, the final frontier. There's been a lot of movement towards space and furthering humankind via the likes of companies like SpaceX, Virgin Galactic, Mars One, and of course the recent landing of the Mars rover Curiosity.
And yesterday we heard from Esther Dyson, who is in fact a trained space tourist. And today we have the privilege of hearing someone from the supplier side. So please welcome Mrs. Veera Sylvius, Managing Director of Space System Finland, up on stage. Welcome.
Thanks. Good afternoon, everybody. My name is Veera Sylvius, and I'm the Managing Director of Space Systems Finland. And they asked me to tell a few words about how it is like to run a company in the space market. Now I'm going to first describe a little bit the space market in Europe, and then tell something about the critical systems development, and then a few words of our company. Now the space market in Europe, its size is around 5.5 billion euros. And in the very core of this market lies the design, development, and manufacturing of satellite application systems, such as telecommunications, navigation, and Earth observation. Then we would have the launcher systems, since you obviously need to launch the satellites. And then there's a number of scientific missions, including the human space flights and the operating the International Space Station. And then, of course, you need to have a ground support equipment, which is about operating the satellites and receiving the data and so on. Now, the only market area which is actually growing is the biggest one, the satellite application systems, which is divided into telco, Earth observation, and navigation systems. And the customer base is twofold. First, you have the public sector, which is mainly consisting of the European Space Agency, and then the big national space agencies from, for example, France and Germany. And in the private sector, you would have the commercial telecommunication satellite operators, which are dominating. And this is the most, biggest growing sector. And the growth is driven by mainly two facts. There is a growing trend of export from Europe, and in general, the need for telecommunication applications is growing. Now, who are the players in the market? They mainly consist of two large industrial holdings, EADS and Thales. And those players are concentrated in the Central Europe, so it would be France, Germany, Italy, and so on. Then there is a number of other smaller but still huge companies, OHB, Finmeccanica, who are dominating, and the amount for the SMEs is less than 8%. What happens in the value chain? Well, first, you need to, somebody decides to put up a satellite, say the space agency. So they will open a competition for these large satellite integrators, and they would have their own supply chains, supplying components and materials. And the same applies for the ground systems. Somebody needs to put up the antenna for the satellite and then take care of that, operating the satellite. Now, in the downstream sector, then, you obviously need somebody to use actually the telecommunication or Earth observation data or the navigation signals. And now there is a growing trend of actually taking care that these satellites, which are extremely expensive to build up and launch, would add some value to the end customers, which are the taxpayers at the end of the day. So the thing that is very much under interest nowadays is integrating actually these applications. So to put up the data from the Earth observation together with the navigation data and the telecommunication facilities in order to, for example, enable air traffic management or maritime surveillance or civil security. Now, if somebody would be interested in operating in the space market, there are certain barriers to entry. Well, first of all, the market is extremely established and conservative. So that the big conglomerates that have their established supply chains and they don't like change. Everything is very competed and regulated. And in addition, the national industrial politics play a certain role. So to be able to sell anything in those markets, you will have to lobby, for example, the space agency to convince them that your thing is actually worth doing. And then lobby those large satellite integrators, and then lobby also the national industrial delegates. Then everything is extremely slow, so nothing happens in 1 year or 2 years. We are now preparing a proposal for something that's going to be sort of really be launched in 2020. So it's really years go by before anything happens in those processes. And then the projects tend to be risky, so you will have to promise to deliver with a fixed price for something that is very vaguely defined or specified. And then everything that is launched into space needs to be space qualified. And that's a process that I'm going to describe a little bit later. Now, talking about the critical systems development, currently there is 8 satellites flying with onboard software that has been manufactured by us. And I'm going to describe some challenges that we've had. Well, first you have GOCE, which is a low Earth orbiting satellite with a very specific mission. It's flying on a low Earth orbit, so it has atmospheric drag affecting it. But the onboard computer that it's having is really weak, so your mobile phone would be like 4 times more powerful than the computer that is flying this thing. But still, the software needs to be able to accomplish really complex tasks. And it's completely mission critical, so once it's launched, it's not supposed to fail, since the time window to the antenna to the ground is always 5 minutes at a time. It's flying so fast over the antenna. So there's really no way that it can be patched. Another mission, Herschel, it was launched 3 years ago, 1.5 million kilometers away, and it's measuring the origins of stars and galaxies, and it's cooled down to close to absolute zero. And it has a huge mirror, which was, by the way, manufactured in Finland by a Finnish small company in Turku. And it's flying also with a weak onboard computer, but the software that is flying it is responsible for extremely complex tasks. So the design needs to be really sophisticated. It was launched together with Planck, and they share partly the same software. And then there are mission-specific parts as well. The challenge when making those is that the software is completely mission-critical. So everything needs to be tested with a 100% test coverage in the unit testing, integration testing, and functional testing phases. So the software needs to be sophisticated in design, but also completely reliable. We had a real-time test environment running 24/7 regression testing. And to be able to run through the tests for the onboard software, it took 5 days at a time. So basically, safety-critical software is always made in a waterfall manner. But here, since the requirements were changing all the time, we had to do incremental deliveries. So that at the end of the day, during the 5 years of this project, we made 52 formal safety-critical software deliveries. Basically, what happens before you even end up doing any software for that kind of applications, there is a huge amount of failure mode analysis, risk analysis, dependability analysis. So the safety is actually very much inbuilt the design, so that before you even have one single requirement, you have made several hardware-software interaction analysis and that kind of things. By the way, the same applies to any application area where software is responsible of something that is safety or mission critical. like, for example, the nuclear power plant industry, the instrumentation and control, medical devices manufacturing industry, and so on. Now, a few words of our company. Space Systems Finland is a 23-year-old company, and turnover this year will be 3 million euros with an EBIT of 10%. We have been growing this year, will grow more next year. And the company is privately held, and I think, and that's my opinion, but I'm the managing director, so I think we're doing very well. And the one driver for this is the fact that we made a management buyout in 2011. And after that, we have been able to establish a certain kind of culture of doing. We're not only working in space. Space is actually less than half of our turnover, but we also work for nuclear industry. And our biggest customer is from medical devices manufacturing industry. But the point is that it's exactly the same thing, that we, like the making safety critical software is really inbuilt our DNA. Now, what is it like to run such a company? In my opinion, it really boils down to facilitating the work of our engineers. So we have 30 extremely intelligent and capable software developers in-house. So there is no way of the management going and tell them how to do their job. But what we have to do is to make sure that they are happy, as far as we can influence that. Order pizza when they're hungry, be nice, trust them, give freedom, stay humble, and make sure that they have projects all the time. And the MBO was a driver for that cultural change. I have to emphasize that. And also one driver would be the fact that we are 3 in the management. And 3 is a good number. I think 4 would be too much and 2 too little. So 3 persons, and we share the same sort of ideology about how to run a company and what kind of cultural values we need to emphasize. Because at the end of the day, as in life in general, it's all about having fun and enjoying. That's it. Thank you.